today we are going to discuss, the topic is everything about MBR, membrane bioreactor. Do you have your permission? Please give a thumbs up. And guys, today's topic is everything about MBR. It's a deep dive and a 1 hour session in which 45 minutes will be my presentation, followed by 15 to 20 minutes of your various questions and answers. What we are going to discuss here today is a recap of biological treatment. In 5 to 10 minutes time, we'll just recap for the benefit of those who have not joined in the previous sessions. What exactly is sewage, why we need to treat sewage, how it is done, and why do we need MBR? There are so many other technologies like MBR, SBR, extended aeration, electrocoagulation. Why one more process? This is one of the major things that we are going to discuss. And what is filtration with membranes? What are the advantages, disadvantages, and MBR flow chart, how it works, what are the various equipments, what are the process tanks required, and what are the various types of membranes available, submerged membrane versus external side stream membrane. And where is MBR ideal? Where can we use MBR? Where can we not use MBR? And what are the problems that are likely to come in MBR while you're using it? And long-term sustainability of MBR versus ultrafiltration. Right. As we all know, sewage, basically sewage means the waste, the water that is coming from our homes after our usage. Please understand the word home. The same water, if it is coming out in a different setup, let us say you're there in a hotel, you're using the same water for same purpose, like bathing, washing of your clothes. Technically, it is not called sewage. Same water is used in a hospital also. Technically, it is not called sewage. Same water is used for cooking and washing of dishes in a restaurant. It is not called sewage. It's got a different name, effluent. Right. Only in a residential setup, we call it sewage. And what is the composition of this sewage? 99.95% water, 0.05% impurity. And all our efforts, the discussion here is to remove that 0.05% impurity. What is the composition of this 0.05% impurity? It is primarily suspended solids that are coming from our food, that are coming from our fecal matter, right? And that is coming from our washing of utensils, cooking activities. So primarily food particles. Secondarily, oil and grease. Oil and grease that comes from cooking activities, like when you have a coffee, there is a small leftover fat content in that. That is also there in the wastewater. Then oil also comes from our bodies when we wash our body and hair, when we wash our clothes, when we wash our utensils. All this comprises of oil. And the second biggest contribution to wastewater, or the strength in wastewater, is the detergent that we use. Every day we are using more and more powerful usage, detergent, like for washing of our clothes, washing ourselves, washing of our hair, right? Washing of dishes. All these places we are using detergents. So all these detergents contain linear alkyl benzene, LAB. So this chemical is present in abundant quantity in sewage, and this has to be removed before this sewage is let out into the environment. And also, it will have some dissolved impurities, like which are actually not impurities technically speaking, ammonia, nitrogen, phosphate. These are the things. And it may also contain, it will also contain a lot of living organism, microorganism, which comes from our human intestines. So the misnomer that we all have is sewage means the water that is coming from toilet. Sewage is definitely the water that is coming from toilet, but primarily the strength comes from kitchen and organic content. All right. Now, why should we treat this sewage? If we just go back and look into the discussions, first is, if you don't treat sewage, it goes into our lakes. From the lakes, it goes into our underground water. From underground, again, we reuse the water, and we are being subjected to a lot of waterborne diseases, right? And rainy season comes, you have plenty of cholera, malaria, these kind of waterborne diseases coming up. There is a spurt in diseases whenever there is fresh rain, which is directly connected to water. And secondly, indirectly connected to water, which a lot of us are not realizing, is the increase in the number of people suffering with cancer, etc. Right? There is a direct correlation on the pollution levels to our well-being. So this is reason number one, we need to treat sewage. World Health Organization says that more than 1 million children die every year because of waterborne diseases. And primarily, 80% of them come from developing countries like India or underdeveloped countries like African countries. Okay. Now, the second disadvantage that happens is lakes have a lot of algae blooms, a lot of plants grow in lakes, and these plants grow and cut down the oxygen supply to the lower levels of lakes, and lakes start stinking. Fish cannot survive in lakes when the water is polluted. And the third reason is why we should treat sewage is we have to meet discharge standards of government. Government has realized that this untreated sewage is like a time bomb, and they started putting more and more stringent conditions on bulk generators of sewage. Let us say an apartment complex, a shopping mall, a hotel, hospital. So wherever there are people, there are rules pertaining to treat and discharge of sewage. Practically, you can say wherever there are 100 people today, that building needs to have a properly designed operational sewage treatment plant as per the existing government norms. So one of the main reasons why we install sewage treatment plants is to meet discharge standards. Now, the last but not least important is to treat and reuse water. A lot of cities, every city as a matter of fact, is suffering with water shortage. When we are using water, we are taking the water either as a surface water or groundwater using our bore wells. We are drawing a lot of water, but we are not recharging. All our treated sewage is going into nearby streams and going away from the place of use, so resulting in groundwater depletion. If you look at cities like Hyderabad, Bangalore, already bore wells are going as deep as 1600 feet. There also we are not finding water. If we don't give water from the top, we can't draw it again, right? So we need to have a source of water which is reliable, and sewage is a most reliable source of water. As long as we use water, we get used water, and this used water can be treated. That means that 0.05% impurity, whatever we have added in the usage, we can remove, and that becomes 100% pure water, and we can reuse that again and again multiple times. So this is reason number 4, and most important reason, and most important from the perspective of today's topic, why MBR. Okay, from that perspective, it is important. Now, why we have technologies like MBBR, SBR? Why not MBR? Why do we need MBR again, afresh? Why more? The last 2 reasons. In the last slide, if you see, one is to meet regulatory discharge standards. Second is enable water reuse. What are the regulatory standards that require MBR usage or advanced filtration usage? If you look at states like Karnataka and Kerala, Karnataka has a stringent BOD norm of 10. They are saying, the local pollution control board in Karnataka says your BOD should be below 10 if you want to discharge the water. Kerala has gone one more step ahead. They are saying BOD should be below 5. And conventional processes like MBBR, SBR, extended aeration, with their traditional tertiary treatment using sand filter, carbon filter, cannot give us BOD below 15 or 20. If we have to get BOD below 10, we need to have an advanced filtration process. This advanced filtration process is nothing but ultrafiltration, right? We'll deep dive into what exactly ultrafiltration is. But one of the main reasons why we want to reuse water, why we want to set up ultrafiltration in places like Karnataka and Kerala is to meet the compliance norms, right? This is apart from the water reuse. Now, whenever we are talking about a city situation like Bangalore, Hyderabad, Delhi, or Chennai, there is tremendous water shortage. We have to reuse treated sewage. And when we are using treated sewage, there is a problem. If the BOD is 10, 15, 20, this water is going to stink whenever we flush our toilet. This is complaint number 1 and headache number 1 for every builder. Every builder, whoever is planning for reuse of treated sewage. And please understand, reuse of treated sewage is not a choice anymore. Builders are forced in their consent letter that they should put a dual plumbing line where treated sewage has to be used. So there is no option on reusing treated sewage, especially in places like Karnataka. Even in Hyderabad now it has become mandatory. So here we need to have this advanced filtration. There is no substitute for that. And we might as well understand what we are doing so that we do a better job of it. And conventional tertiary treatment comprising of sand filter and carbon filter cannot give you this kind of treated water. Hence, the need for the better process. The better process is, let us understand what is filtration. Please understand, there is a difference. MBR is not biological treatment. That means a lot of people assume that MBR and MBBR are replaceable words. No. Every biological treatment is separate compared to tertiary treatment. All our membrane filtration is a part of advanced tertiary treatment. All right. Now, if you are just looking at this screen, you will understand that we are here. We are talking about this, right? Micron filtration. Without micron filtration, we are talking about multimedia filtration. That means sand filter and carbon filter. Sand filter and carbon filter can remove up to 10 micron. That is a best maintained sand and carbon filter. Normally, typically 100 to 50 micron, 100 to 50 micron is what they can remove. Beyond that, they cannot remove. So if we want better clarity of water, where we are removing bacteria and virus before we reuse this water, then we need to go for ultrafiltration. The next level of treatment after ultrafiltration is nanofiltration and reverse osmosis. A lot of us are familiar with reverse osmosis. We use it in our homes for drinking water purpose. Right? That is not the topic of discussion here today. Right. Microfiltration is also not something that we are using today. Microfiltration is again a next topic. Right. Today we are most conventional STPs use up to sand filter and carbon filter, which can take out up to 100 micron particles. That is 0.1 millimeter level particles they can take out. Right. By going for ultrafiltration, we are not only able to take out the suspended impurities, but also we are able to take out bacteria and virus. Let us go back and see what is the size of bacteria and virus. Please look at this. Bacteria is 0.1 and virus is 0.01 microns. And 1 micron is 1 by 1000th of a millimeter. 1000 microns make 1 millimeter. All right. Now, this is a membrane specification from a membrane manufacturer called Torre. Here you will notice that pore size in ultrafiltration membrane, or this is MBR, is 0.08 microns. You can see this here, 0.08 microns. Okay. So let us understand what exactly is this ultrafiltration and how it works. Now we understood ultrafiltration is the next level of treatment after micron filtration. That is media filtration, micron filtration, ultrafiltration, nanofiltration, and reverse osmosis. This is the filtration spectrum, right? Okay. Now, the major force that drives or that makes ultrafiltration work is the pressure, the differential pressure. If there is a differential pressure, imagine like a cloth filter, like on a piece of cloth, you are pouring water. So any particle bigger than the pore in the cloth will get blocked by the cloth. So the water will go into the next stage. That is, it will flow through the cloth. If it is sand, the sand gets stuck. It is blocked by your cloth. Imagine you put more pressure on the cloth. Then some more particles which normally do not get through the cloth will also pass through the cloth. The same principle is applied here. So we use what is called a membrane. Membrane is nothing but a chemical-based cloth kind of, say, right? And it is folded and made it into a round particle, something like a string, something like a thread, right? What you are seeing here is a membrane. The middle path, the middle one, is the treated water. On all sides of the membrane, there is raw or treated sewage, which may have come from biological process. And after sand filter or carbon filter, if it is external UF, right? Now we are applying pressure on all sides of the membrane. So due to this pressure, clean water gets into the middle of the membrane. The bigger physical impurities, including bacteria, virus, remain on the outside surface of the membrane. They can't get into the membrane because of the pore size. This is a very simple physical phenomena. There is no rocket science in this. It is just that as we keep on putting pressure, more and more physical impurities will get stuck on the membrane surface, and at some point of time, it does not allow water to flow through. At that point of time, a sensor will sense that there is huge pressure difference and reverse the flow. That means from inside, you backwash. You give water at a higher pressure from inside so that you pulse away the accumulated particles into the drain. At the same time, a drain valve would open and all the backwash water containing the impurities that have been blocked by the membrane will go into the drain. This is a very simple process. There is no great science, rocket science in this, right? Now, ultrafiltration is available in two configurations. One is a submerged ultrafiltration membrane, which is normally known as MBR or membrane bioreactor, or an external ultrafiltration membrane, which is normally known as ultrafiltration. Some smart people also call ultrafiltration as side stream MBR. Suppose some client is asking you for MBR. He says, send me a quotation for 500 KLD MBR. If you are smart, you probably might say, I'll send a proposal for ultrafiltration, but I will rename it differently. You call it side stream MBR, right? And some people also call MBR as submerged ultrafiltration membrane. These names are interchangeable, but the bottom line is the concept of working, whether it is submerged or it is external, is same. It is the pressure difference or the delta P which is causing water to go into the membrane, and periodically you backwash to remove whatever is accumulated there. When you are backwashing, you might add a small quantity of air if it is a submerged membrane. Some UF membrane manufacturers also insist that you should flush it with a lot of air so that these particles which got blocked there by the membrane are dislodged more rigorously. Your membrane works much better when you are purging with air, whenever you are backwashing. All right. So please understand, ultrafiltration is available in two configurations. One is a submerged membrane, which is called MBR, and the second is a external membrane. Now, why these two configurations? We have cars, we have number of cars, right? Very soon we'll get cars that will fly. Very soon we are getting cars that will probably swim in water, that will float in water. All right. In the same manner, we have a different application of an external membrane in the form of a membrane bioreactor. It is only for commercial reasons that they created a different product with a different application nature and start selling it. All right. Now, let us see how the pressure difference is created in a submerged membrane. A submerged membrane, or a MBR as we are calling it. The MBR, you are seeing this, there is a pipe here, this is a header pipe. On one side of the header pipe, you connect to the suction side of the centrifugal pump. A pump which is kept outside the tank, you connect it there. When the pump is running, a partial vacuum is created inside the housing of the pump, inside the line. Because of this partial vacuum, and please understand, this membrane is submerged in treated sewage, and there is atmospheric pressure. There is partial vacuum, that is negative pressure in pipe, and there is zero pressure here. That means positive pressure on the atmospheric pressure on the water side. Because of this pressure difference, water gets pulled into the membrane. Water is pulled into the membrane by the vacuum, right? So in normal language, you can call it a pull, right? The difference is maybe 0.1 kgs to 0.2 kgs in terms of pressure difference. All right. Whereas in a external ultrafiltration membrane, it is push. Treated sewage is connected to the delivery side of the centrifugal pump. You are pushing water at a pressure. When you are pushing water inside the membrane, there is no pressure. Outside the membrane, there is pressure. Because of this pressure difference, water flows into the membrane and gets carried away to the next process tank or storage tank. So the difference between these two membranes, submerged and external, is submerged works on the principle of pull by creating a vacuum. External one works on the principle of pressure by push strategy. Both require a pump, whether you are connecting to the suction side or the delivery side. All right. Now, we all know as science students that it takes more energy to create vacuum than pressure. Creating a 1 kg pressure is relatively easy. Any small pump also today is capable of giving you 1 kg pressure. All pumps can give that kind of pressure without any issue whatsoever. Maybe exception of submersible pumps. Any centrifugal pump will easily give you 1 to 1.5 kg pressure. But the same pump may not be able to give you that kind of vacuum, right? So it takes more energy to create vacuum than create pressure. All right, let's move forward. Now, what we are seeing here is a conventional activated sludge process. What we are doing here is, in a conventional activated sludge process, there is an aeration tank. Then whatever biological process has to take place, it takes place in the aeration tank. The bacteria eats what we want to take out, and then the water goes into a settling tank. A settling tank is also called clarifier, where we are settling out the heavier particles, including dead bacteria. Clear water from the top layers of the settling tank goes for sand chlorination, and then sand filter, carbon filter. That is a conventional activated sludge process. Whether it is MBBR, SBR, the process might change a little bit, but otherwise the underlying principle is same. It is basically bacteria that you are growing it eats what we want to take out from water. That particle may be visible to us with naked eye or may not be visible. All right. Now, how this membrane works? We'll just go back in the video a little bit back. Okay. So a membrane is kept in a tank. Please understand this. A membrane is kept in a tank after aeration. The tank is called MBR tank, where you are sending biologically treated water. Right. This biologically treated water again is aerated from the bottom. The submerged membrane needs a little bit more air because we don't want those physical particles to clog there. In most of these membranes, the backwash is not very strong. Unlike an external UF membrane, in dissolved membrane, in submerged membranes, the backwash is not done with external water. Here it is done using air. You just reverse the cycle, you stop the pump, and then you flush a lot of air. You send a lot of air, expecting that the impurities that they have got lodged on the membrane surface are washed away because of air velocity. Right. This also makes the submerged MBR process a little bit more inefficient as compared to our MBR process. You can see here the video. If we just go back and see the video again, what you are seeing here is the membrane, and this is the membrane. If we go deep dive, these are the membrane fibers, and this is one fiber. Probably we are seeing in an electron microscope level. We are seeing that water is getting pulled into this, and what you are seeing here, this blue colored and black colored one, is the support structure for the membrane fiber. All right, the physical particles are the black colored items. They are getting blocked on the sides of the membrane. They are not going into the membrane. So when you reverse or when you switch off the vacuum pump, this process will stop. Water is no longer going. At that point of time, you start giving a lot of air. You score. Air scoring means you give large quantity of air using a solenoid valve. So at that point of time, whatever is dislodged there gets washed away. This is the principle of working for submerged ultrafiltration membrane. This is one of the installations where a separate tank has been used, right? And please understand, sludge is continuously pumped back into the beginning of the process. That means most MBR tanks today have an anoxic tank to begin with, a collection tank, anoxic tank, followed by aeration tank, MBR tank. From the MBR tank, again, treated sludge or the sludge settling at the bottom of the tank is sent back to the anoxic tank. This is a continuous loop process. Also, you need to maintain the same level of water in both the tanks, MBBR as well or aeration tank as well as the membrane tank. All right. Now, if we can just qualify what exactly is MBR. MBR is a conventional sewage treatment plant plus an ultrafiltration membrane kept in the process. A conventional STP without tertiary treatment up to biological level, it is the same. That means the bacteria is grown to eat what we want to take out. Treated water only can go into the membrane. If you put a membrane into any biologically treated STP, biological STP like MBBR, SBR or any MBR, on day 1, definitely you will not get the kind of water that you get on day 20. The reason being, biological process is a slow process. It takes time for bacteria to grow in required quantity and give the desired quality of water. So please understand, MBR also needs biological process. This is a misnomer. This is a misunderstanding for a large number of builders that I interacted with, including some of our salespeople. Even salespeople, seasoned salespeople tend to feel that MBR does not require biological process. No, MBR is only the last stage of a biological process. In the last stage, you are removing tertiary treatment and you are putting a membrane filtration. The difference is that a membrane is submerged in water. So we tend to feel that it is one and the same. The reality is this requires much more stringent water quality. For example, oil has to be taken out completely. Membrane manufacturers say, my membrane is oil intolerant. That means if there is an oil in the incoming water, that oil cannot be allowed to go into the membrane because it will form a layer and that layer becomes difficult to clean. Please understand the limitation. You are putting the membrane into the tank. It's very difficult to take out the membrane again, put it outside and clean. There are lots of limitations, practical limitations. Again, you need to have a separate storage facility for that membrane. If you want to do external cleaning, you need to have a tank of the size of the membrane. You need to have a conveyor or the chain pulley block which is pulling up the membrane from water. and transferring it to the required location. This is all more capital cost. So a submerged membrane is a lot more expensive compared to a external membrane. All right. So now let us just do a small comparison. Which is better? Which has which benefits? The water quality is same because the principle of working is same whether you are using an external membrane or a submerged membrane. The water quality cannot be different. Energy point of view, you require more energy in submerged membrane because you have to create vacuum. Not only that, you need to provide for air continuously. The air, more air is required to purge whatever physical particles are getting accumulated there on the membrane surface. So you require air for purging, number one, which consumes more energy, and also you require what is this? You require a vacuum pump or a pump, centrifugal pump, which has to run at a higher capacity. With respect to this, UF is better compared to MBR. And cleaning. How do we clean MBR membranes? MBR membrane cleaning, what membrane manufacturers specify is periodically. That means at least once in a year, you need to take out the membrane physically from the membrane tank, put it in an external tank, maybe made up out of MS or stainless steel or fiberglass, and give it a chemical bath, which is a cumbersome process by itself. And creating infrastructure for such process is again capital intensive. That means I need to put a chain pulley block, maybe a motorized chain pulley block on top of the MBR membrane. That means I need to have headroom first to pull out the membrane. I need so much of space above the MBR tank, and then I need to have a conveyor system which will convey this membrane when I take it out into the required storage area or tank, and then I need to fill that process tank with chemical, clean it, and disposing of that chemical is again a Herculean task. So cleaning of MBR membrane is not easy. It's cumbersome. Whereas an external UF membrane is relatively simple. It's as simple as we just provide a CIP pump, we open few valves, clean it, because there is an external covering. A membrane is already kept in a poly PVC cover, a PVC pipe by the manufacturer himself. So every OEM, when he's installing this kind of equipment, he will provide for CIP pumps, clean in place pumps. So cleaning becomes a lot more easier. There is no great risk involved in cleaning, right? Of that chemical, the quantity of the chemical we use is also very small compared to MBR cleaning. You can also use relatively harsher chemicals because we are putting the membrane in a case already it is there. So there's no problem in using strong acids or strong alkalis for cleaning of the membrane, which you cannot do if you are doing the cleaning in a concrete tank. All right. So cleaning point of view, UF is far better. External UF is far better compared to a submerged MBR. And when it comes to replacement, same logic applies. It's like taking out one membrane and putting back a UF membrane is a couple of hours job. Whereas it takes 1 to 2 days if you have to do the same replacement for a submerged membrane. Again, same process. Lift it with a crane or electric hoist, which is installed above the tank. Pull it up, take it out, and put back the same thing. Stop the process. Your biological process also has to stop that time. Right. Now, what are the other things? So from replacement point of view, UF is far more better. I'm not talking about commercial point of view. It is from the working point of view. Now, input parameters, are they both require same kind of input water quality? MBR membrane manufacturers specify stringent input water standards. They say your oil should be free from water. Please understand, what we are feeding into the MBR is biologically treated sewage. It will still have some quantity of oil. You might have kept an oil filter, oil coalaser, or oil and grease tank using an oil removal mechanism, like a belt skimmer or something like that. Still, you cannot remove 100%, right? So for such cases, the scaling potential is increasing drastically when your oil is not removed completely in a biological system. So MBR membranes are less tolerant to variations on the input water quality. Whereas an ultrafiltration membrane, which is external, is probably installed after the water is treated, or after sand filter or carbon filter, or at least there is a micron filter in between. There could be a disc filter. So there is some kind of filtration mechanism. which is removing all the physical impurities from going and attacking or destroying the membrane. So UF membrane is a lot more tolerant compared to a submerged MBR membrane. Now let us look at the capital cost. The capital cost of submerged ultrafiltration membranes is 3 to 4 times that of external UF membranes. And not only the membrane cost, the attendant infrastructure required, like you require a separate MBR tank, then you require a external hoist on top of the tank to pull up the membrane whenever required, or to replace or put it back in the place, right? And then you also need a CIP tank, a cleaning tank for these membranes. This is what the membrane manufacturers are specifying. Some of us cut corners, we may not provide these in place, but as per the manufacturer's recommendation documentation, these are all essential. So from CapEx point of view, ultrafiltration is much, much comfortable. Not only for the capital cost, after 5 years, after 10 years, whenever the membrane comes for replacement, if you are using X brand of, let us say you have used GE membranes, MBR, GE MBR, when you are replacing also, you have to still use GE MBR only. It's very difficult to retrofit with another manufacturer's membrane. Whereas in external ultrafiltration membrane, you are not manufacturer or brand dependent. You take out this membrane without affecting your process in any manner, right? So by all means, except for the fancy of a membrane process, external UF membrane is much, much better as compared to a submerged MBR. Right, let us look at the flow chart. How water flows, how sewage flows. Screening. A good screen is essential for any biological process, more so because MBR membrane fibers are getting exposed to physical particles that are coming into the sewage. So any physical particle going and brushing by this side will cut the membrane fiber. Membrane fibers are very small, less than 1 mm in size, right? They can be cut easily. Although they are made up of strong materials, they can still be cut, right? So accidentally, some particles could get, some strings can get torn away also. So your screening has to be a lot more stringent. You need to screen up to a level of 2 mm without failure. Normally in any biological STP, the screen that we put is 5 mm. We might put a 20 mm or 25 mm core screen followed by a 5 mm fine screen. But when you are using an ultrafiltration membrane or when you are using a MBR membrane, you need to go for screens which are of the level of 2 mm. And then, like we discussed earlier, oil has to be taken out. MBR membranes are not oil tolerant. This oil can go and form a layer on membrane surface, affecting the performance. So oil has to be taken out before membrane is used, before MBR is used. So taking out oil poses its own challenges. You can remove oil to a level of 1 ppm, 2 ppm, but beyond that becomes a lot more difficult. You need to provide more storage tank facility, which is again a capital cost, right? Then after oil and grease tank, the water is going into your equalization tank, right? From equalization tank, some membrane manufacturers insist on having a anoxic reactor. From anoxic reactor, it goes into an aeration tank. From the aeration tank, it goes into an MBR tank. Some other manufacturers, some OEMs say, my membrane does not require a separate membrane tank, but the reality is the membrane manufacturers are recommending that there should be an anoxic tank, there should be an MBR tank, right? So the aeration tank overflow goes into the MBR tank. From the MBR tank, the sludge is taken out and pumped back into the first stage. Any excess sludge goes back into the sludge holding tank. From MBR tank, we are straight away from the MBR membrane, we are straight away getting clear water. This clear water just needs to be chlorinated before reusing it for any purpose. All right, and sludge treatment is same whether you use MBR, SBR, or whatever process is used. Your sludge dewatering is same, because MBR is not biological process. I'm repeating once again, MBR is only an external advanced tertiary treatment. It has got nothing to do with a biological process. All right, now compare this with the external UF process. Any external UF process can be installed in an existing, please understand this, in an existing MBBR, SBR setup also. The footprint will be very small. So you are not tinkering with your MBBR or SBR process. You can have your MBBR or SBR, which your process requires, and then after chlorination, water goes into an ultrafiltration membrane, which is kept outside the tank in a pump room, right? Using a pump, you are pushing water at 1 to 1.5 kgs pressure into the ultrafiltration membrane. Treated water is coming out, and ultrafiltration systems are typically automatic. They backwash every 30 minutes, every 40 minutes as you program. There will be a very small PLC or a microcontroller which is controlling the performance logic. The same is the case with MBR also. MBR is also backwashed automatically. Some membrane manufacturers say every 11 minutes, every 18 minutes, every 20 minutes. But the cleaning frequency is little less in MBR as compared to MBR. Cleaning frequency is little less in ultrafiltration membranes as compared to MBR. Okay, MBR membranes require a pulse or backwash every 11 to 20 minutes. Ultrafiltration membranes require cleaning every 30 minutes to 50 minutes or so, depending on the suspended solids load. Suppose you have a proper sand and carbon filter. After sand and carbon filter, you are putting UF, then even 1 hour backwash is also sufficient. If there is no sand and carbon filter, from your chlorine contact tank, you are pushing it into the ultrafiltration membrane. At that point, you might require little more frequent backwashes every 30 minutes, every 28 minutes, 25 minutes. You have to do a small test, and then your membrane manufacturer will specify what should be the frequency. And the backwash duration is typically never more than 60 seconds. It can be 30 seconds to 60 seconds in both MBR or UF, right? So sludge treatment is not related to ultrafiltration, because ultrafiltration is an external thing. You will still have your MBBR or SBR as your process demands. That means if you are in a place like a hotel, hospital, where your incoming sewage is fluctuating, you don't know how many people are going to be there in the hospital tomorrow. You don't know what will be the occupancy in your hotel tomorrow. In such cases, SBR is ideal. But when you put an MBR being a biological system, it's very difficult to maintain the flow, very difficult to maintain the integrity of the biological process. So MBR may not be suitable for applications where you have variable loads, fluctuating loads. It is more amenable for processes where there are constant loads, plus or minus 10%. All right. So this is one more limitation of the MBR. All right. Now, what are the process tanks required? We'll look at process tanks required for both submerged membrane as well as external membrane. A collection tank is always required. Anoxic tank, as per membrane manufacturer's specifications, with 1 to 2 hours retention time. And a proper mixer is also essential. If the plant is large, you need to have a mechanical mixer in the anoxic bioreactor. And aeration tank. In the end of the aeration tank, there will be a MBR tank. From the MBR tank, you are pumping back your sludge into the anoxic tank. All right. And then a sludge tank for sludge digestion, and a treated water tank. These are the MBR process tanks. All right. The fact that you are putting MBR means you want to reuse the water. If you don't want to reuse the water, probably there is no point in putting a treated MBR. And then if you are not putting a treated water tank after having MBR, you are wasting resources. All right. So what are the process tanks required for ultrafiltration? There are no additional process tanks required for ultrafiltration. The same process tanks that are required for MBBR or SBR are sufficient for ultrafiltration. You might, in case you are using sand carbon filter, you might need a small treated water storage tank for ultrafiltration treated water. All right. So same tanks are required. There is no need for additional number of tanks. So what are the problems that come when you are using either MBR or ultrafiltration? See, please understand this. I have come across cases where people are complaining my water quality is not good. Your water quality not being good is not dependent on membrane. It is dependent on your biological process. If your biological process is not stabilized, if it is not good, if it is not giving you clear water, membrane cannot do much. Membrane is only doing a physical filtration, right? It cannot remove your dissolved organic content. Please understand this, right? So the problem of poor water quality has to be settled by tinkering with the biological process, not with the membrane process, right? And okay, this is why a lot of OEMs are recommending MBR. This is the question I ask the client himself. Wherever I go, whenever a client says, I want MBR, I ask him, why do you need an MBR? He says, I want to reuse the water, or I want to give better quality water. Then I ask, how much quantity you want to reuse? First, they will begin with, we want to reuse 100%. I ask them, where will you reuse 100%? You will use it for bathing again? No. You will use it for flushing? Yes. How much water you will use for flushing? 25 to 30%. Then what else? We'll use it for gardening. How much area you have for gardening? They'll say X amount of area. How many acres is that? Y. Okay. So per acre, you can probably discharge 10,000 liters per day. That is if you have land where water is going into the underground strata. Most projects today, residential projects today, where they are planning for MBRs, they don't have any vacant land. It is podium style. That means you are seeing the soil, seeing beautiful lawns, but below that lawn is a RCC roof. If you put water, it will not go into the ground. So in such case, why do you want to put an MBR at a huge capital cost, treat water to the highest possible level, and then throw it out? It doesn't make any sense, right? But why vendors are recommending? Because vendors have a vested interest. If I am a STP vendor, I want to sell a project of 1 crore rather than sell a project of 50 lakhs. If my business target is 10 crores per annum, I just want 10 customers if I'm selling 1 crore project. If my target is same 10 crores, if I'm doing a 50 lakhs project, I need 10 more customers, 20 customers I require, which is difficult to get. So from a vendor's point of view, it is a win situation to have a MBR. Not only that, a customer who is buying an MBR will probably maintain it properly. So most MBRs present today are there in IT companies, industrial parks, or high capital cost buildings like shopping malls, etc. But the point is, are these guys capable of maintaining it? That is where again vested interest comes into picture. A person who spent 1 crore on STP would not put it on in the hands of every Tom, Dick and Harry. 99% the O&M will also come to us, and that too at a price that we want. So I'm not only doing better business initially, my business value is more when I'm selling MBR STP. I am going to get a recurring income by way of O&M. This is the reason number one why most STP OEMs are insisting on MBR to their clients, right? And also, clients do not have knowledge. They don't know the difference. They don't know the deeper knowledge. They don't have deep knowledge. They have superficial knowledge to understand the difference between UF and MBR. Of course, consultants do have this kind of knowledge, but consultants again have their own system of working, which I would not like to right. So, which is better? Finally, MBBR or SBR plus an external ultrafiltration membrane. As a learned person, we would always recommend a biologically treated sewage treatment plant, that is with MBBR or SBR, plus an external ultrafiltration membrane of smaller capacity. Of what capacity? Whatever is your intended reuse. You want to reuse it for flushing. Flushing cannot take more than 30% of sewage. So put a 40% UF. Instead of 30%, go for a 40%. That means if I'm having a 500 KL MBBR, then 500 into 40% is 200 KL. Go for a 200 KL UF system. It saves you money for capital cost as well as operating cost. All right. Thank you so much for your patient listening. Now we are ready for your questions. I'm stopping sharing of the screens. Back again. Okay, your questions now. You can unmute yourself, all of you, please, and your questions.
Shekhar sir, you have a question you can ask.
Yes, sir. I have a question.
Yeah, please.
MBR plant, in case of it is a 250 KLD.
Okay.
And also 300 KLD. What will be the cost of installation?
What will be the
approximate cost, total cost of MBR plant?
See, civil apart, you require membranes, depending on the brand. Now, Genpack or GE makes membranes in India. So GE MBR membranes are relatively cheaper. Toray makes them in Japan or Indonesia, and Toray membranes are slightly more expensive. Then if you go for those membranes, those things are sold as modules. A 50 KLD module, a 50,000 liters per day module, Toray module. Last time we bought for something like 11 lakhs each. So in a 300 KLD STP, you might need 6 modules. 6 into 12 lakhs or 11 lakhs. That makes it 66 lakhs is your membrane cost. Add another 5 lakhs towards automation, your PLC, then your valves, your CAP mechanism, all these things. So 65 to 70 lakhs is your capital cost for membrane alone. Apart from this, you add whatever you would like to add for your biological process, your membrane process, your diffusers, your blowers, your control panel, all these things. So a 250 to 300 KL, 300 KL STP, in my knowledge, can go for something like 90 lakhs to around 90 lakhs. That should be a selling price, including membrane, including blowers, including everything. So, Mr. Shekhar, did this answer your question?
Sir, I have one question over here.
Yeah, please.
Sir, means how do we select the system, like whether it is MBR or MBR or SBR, on what basis do we select the system, first of all?
Sir, first the starting point for any STP selection is what is your intended reuse? Why are you putting up an STP, right? Suppose you are putting an STP primarily for meeting compliance requirements. Okay, which is most of the cases it is a compliance requirement. So what are your discharge standards? If I am in Karnataka, my discharge standard is 10 ppm. A properly maintained SBR or MBBR also can give me 10 ppm BOD in the outlet, but that is a border case, right? And nobody is going to measure your 10 ppm BOD on a continuous realistic basis. Whenever you check a sample in the morning or in the evening, you will get a result. And you do have continuous BOD measurement instruments, but those instruments are not meant for field usage. They are meant more for laboratory usage. So the moment you put it in a reactor, your treated water tank, it may not give you the right kind of result. So from the perspective of reuse, first you are meeting compliance, so one tick mark, I need at least 10 ppm of BOD. Then what is your next requirement? You want to reuse this water, you want to throw away this water. If you want to throw away this water, you probably don't need ultrafiltration. You can be done with MBBR or SBR. But if you would like to reuse, how much portion are you going to reuse? 30%, 40%, 50%, right? If you are a hotel, let us say you are a 5-star hotel where you have HVAC requirement, right? Then you might still need some clear water. Apart from flushing, you will also need some water for your HVAC or cooling tower or whatever. In such case, what is the requirement for that application? Add that to your water quantity, add another 20%, and decide what should be your recycling plant. So divide your STP into two parts. First part is a biological treatment comprising of SBR or MBBR. The second part is recycling plant, which can be comprising of UF and, if required, RO also. Okay, so which technology to use is based on, number one, your intended purpose, and second is what kind of wastewater you are generating. What is the nature of your project? Let us say you are a hotel or hospital, right? A 5-star hotel. In a 5-star hotel or 3-star hotel, we don't know how many guests are going to be there on any given day. The more guests, more wastewater is generated. Less number of guests or less occupancy, less sewage is generated. You can't have an MBBR system where one day you give 100 KL, next day you give 50 KL. So the system will not work. For such cases, you require SBR, sequencing batch reactor. All right. And where you have a residential setup, you probably have 10% plus or minus depending on the number of users. So for something like that, there is no point in going for SBR. You better go for MBBR.
Okay, so sir, I'll give you an example. I do have a residential project of 50 KLD capacity, and the
Okay.
space available with me is like 110 square meters.
Okay.
And the space is underground, like it is in a pump room.
Okay.
So, which technology probably I should go with?
Sir, technology, which technology is not dependent on space? See, space is again a question of depth, right? Look at it this way. Any biological treatment process, you would probably require 100% volume to 150% volume. That means if you're talking about a 50 KL STP, right? Your process tanks can be from 75 KL to 100 KL. I'm talking about
Right,
level. So when I'm talking about a 100 KL, 150 KL tanks storage volume, if I take an average depth of 3 meters, I require only 150 divided by 3. 50 square meters of land is sufficient for me. I'm talking apart from pump room, process
okay,
tanks. Okay. So if you are having 110 square meters, so this is not a limiting factor. You can go for any technology that you wish, whether it is MBBR, SBR, MBR with you, MBR or external UF, whichever you require. Since you said residential project, I would recommend MBBR.
okay,
The
right.
space you have is sufficient. Whatever you have is more than enough.
And so one more thing that you show the video of that membrane, the water is flowing from the, it is gets sucked into the membrane and then it is treated. So I just wanted to ask that the membrane is kept in submerged stage in the MBR tank. Then how the water will flow, means whether it will flow upflow, means in upflow direction from bottom to top, or whether it is going from top to bottom. I didn't get that the process of
Sir,
like
please understand
treatment of
this. The way hydraulically it is done is you don't want water is coming from aeration tank, right? That means biologically treated sewage is coming from aeration tank into the membrane tank, right?
right,
From the bottom of the membrane tank, you are pumping sludge. There is a slight gradient to one side of the tank, which we call a sludge collection area. From that area, we put a pump and pump the sludge back into the anoxic tank or aeration tank, whichever is the case. So that being the case, your question of upflow or downflow, it is upflow only. Water is coming from the top in the aeration tank. From the aeration tank top level, it is coming into the membrane tank. So it is upflow. But there is continuous air coming from the bottom of the tank, which will purge or which will not allow suspended particles to form a layer on the membrane surface. So you
okay,
can say water coming from top, air coming from bottom.
okay, right, sir. And sir, what would be the temporary means tentative lifespan of this membrane? Means how much after how much period of time do we need to change the membrane or something?
Sir, this is directly proportionate to how we use our membrane. If we are, membrane is again an organic content, organic chemical. It is made up of some kind of polymer. Polymer means organic, right? So the number of times that you clean the membrane has a direct impact on the life of the membrane. Membrane manufacturers are claiming 5 years to 7 years life, but conservatively you can take it as 5 years, whether it is UF or submerged membrane. Typically, UF membranes, external membranes tend to have little less life because you use harsh chemicals to clean that compared to a submerged membrane. Submerged membrane, taking out and cleaning it with harsh chemicals is a very difficult, challenging task. So it is not done frequently. Even if it is giving lesser flow, see what happens in a membrane is the flow rate keeps coming down. There will be a small layer formed. Instead of getting 100 kl from your 100 kl plant, you start getting 90. After 6 months, you start getting 80. After 1 year, you are getting 50 kl. This is a gradual deterioration in the output performance of your membrane. So at some stage, you feel there is no point in running it, and then you replace it. More questions, please.
Sir, can you elaborate on the backwash process involved for this external or submerged?
Whether it is external or submerged, the process is controlled through a small PLC microcontroller based on a timer. Let us say every 67 minutes, I'm backwashing for 1 minute. So every 60 minutes, my backwash is 60 seconds. In a submerged membrane, it is not possible to flush with fresh water because you are pumping back so much of fresh water or treated water which you have collected into the tank. So what they do there is they switch off the pump which is creating the vacuum, or your centrifugal pump which you are using to pull clean water. You switch off that pump for that backwash duration and increase your airflow, right? When you are increasing your airflow, the idea is you are technically pushing those physical particles away with a lot of force. Whereas in a external UF membrane, we use water as well as air. You give back a pulse of water. Typically, the backwash pumps are 3 to 5 times the capacity of feed pumps. So, in a let us say 100 kL UF is there or 5 kL per hour UF is there, your backwash flow is 3 times, almost 15 kL per hour flow will be there because of this higher velocity. And sometimes we put a air purging also. The cleaning will be the backwash cleaning will be better in external membrane as compared to a submerged membrane.
Okay, sir. Thank you.
Thank you. More questions, please.
Sir, sorry, I got disconnected somehow.
Okay, okay.
I have a last question, sir. I won't
Yeah,
take
please.
much time.
We have time, sir. Don't worry about that. Ask as many questions as you wish.
Right, sir. So, sir, all of this presentation that you have given, so based on that, I have met many suppliers of STP who are claiming that MBR is saving space.
Okay.
Though MBR is costing initially, but it will save you the space. It will save you the tank sizes and everything. So less civil construction, less space is required, so that we can utilize the space for different purpose. So means we should buy MBR or we should avoid MBR. I'm a bit confused from initial. So what do we do and what do we prefer?
Sir, what I suggest is, as educated people, we should take a learned decision. So whenever a vendor is telling you this saves space, you have to tell him, get me drawings for both. Right? Same capacity. Let us say we'll talk about your 50 KL project only. 50
Right,
KL,
sir.
give me a drawing for MBBR and MBBR with UF and MBR. Explain me how
Right.
this saves space. And whenever an OEM is approaching you with some drawings, you tell him, show me the relevant data from the manufacturer's side. See, membrane manufacturers, there are hardly 4 or 5 manufacturers world over, right?
Hmm.
In India, the popular ones are Torre is popular in India. Then apart from Torre, GE is GE or GVID as they call it. GVID is also taken over by GE. So GE happens to be number 1 in India, followed by Torre. Okay, Asahi is also there, but they are not very popular in India. So these 2-3 manufacturers, you have to look at their membrane specifications because the membrane happens to be the heart as well as the most expensive part in your system. Like we discussed now, for 300 KL, the membrane cost, my purchase cost itself is around 60 lakhs, right?
Okay.
So you are going to spend that money after 5 years or after 7 years. If not you, your association has to spend that kind of money. So you have to tell your OEM, show me the catalogs, drawings, membrane manufacturers, recommendations. Get this drawing validated by those people. See, we did a project in Amaravati High Court, Andhra Pradesh High Court building with MBR. We submitted drawings validated by Torre team. From Japan, we shared our drawings to them. They validated our pump sizings, our membrane sizings, our tank sizings. Only when they validated, we got the order, when these drawings were submitted to the client. So please insist, it is an expensive decision to go for MBR. And it should be based on real data as approved by the manufacturer. I am sure your OEM will then give you either right inputs or he will run away from that place if he cannot do that.
Right, sir. Thank you so much.
Okay, sir. Thank you. Guys, any more questions?
Thank you, sir.
Somshekhar Garu, we missed out on you. How are you, sir?
Yeah, good, sir.
Good to see you again. Okay. Sir, any questions from your end?
No, I just asked only the cost of this project for MBR. You say it
Okay.
is one module costing 11 lakhs, approximately 12 lakhs.
Exactly, sir.
If it is 250 KLD, 300 KLD multiplied by 6, 66 lakhs around it is costing.
Yes, yes,
And
sir.
other renovations for existing plant, another
Sir,
30
if you
lakhs.
have an existing plant, it is not required to go for MBR. If you have your existing plant might be MBBR or SBR. Which one you have?
MBBR.
MBBR. So let this plant run properly. In the outlet, you just buy one ultrafiltration system, a 300 KLD ultrafiltration system, something like 300 KL, 15 KL per hour. 15 KL per hour will cost you 20 lakhs.
15 this only can be used only for flushing purpose.
If it is only for flushing, go only for 30% of your 300 KL STP or 250 KL. 30% is 75 KL. So go for at the most 100 KL UF plant. Do not bother too much about your 300 KL or 250 KL. Just go for 100 KL UF.
Only this UF water can be used for flushing.
Flushing.
Yeah.
That will save you money. That will save you trouble.
In case of if I go for a UF, how much it costs for me?
Maybe 5 KL per hour UF is what you would require, right? 5 KL per hour UF, depending on the membrane brand, anything from 8 lakhs to 12 lakhs. Various manufacturers give you based on their input cost, but the ballpark figure is 8 to 12 lakhs.
Apart from this pressure filter and activated carbon filter,
you actually don't have to use them, but you require them if you are putting partial recycling. That means 300 KL will be passed through sand filter, carbon filter. 100 KL will be passed through UF.
That means we have to take a bifurcation and make use of this UF and use for required area.
Exactly, sir. Exactly.
Oh, got it. Thank you, sir.
Okay, Andy. Thank you. Vijay Kumar garu, Vijay Krishna garu, any questions from your end, sir? Although I know you're technically a lot more competent than all of us here, having worked in...
Thanks for the training. Thanks for the support, Andy. But actually, now actually MBR movement వచ్చింది మార్కెట్ లో. yes, we are dealing with MBRs కూడా చేస్తున్నాం కానీ బట్ అల్ట్రా ఫిల్టరేషన్ ఇప్పుడు నాకు ఒకటి సార్, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఒక 100 KLD రిక్వైర్మెంట్ ఉంది. నేను ఇన్స్టెడ్ ఆఫ్ అల్ట్రా ఫిల్టరేషన్ బదులు MBR ప్రపోజ్ చేస్తే ప్రాజెక్ట్ కాస్ట్ ఎంత పెరగవచ్చు సార్ అప్రాక్సిమేట్లీ?
ఇందాక మనం అనుకున్నాం కదండి, 100 KL అంటే ఒక 2 మాడ్యూల్స్ పెట్టాలండి. మీరు 2 మాడ్యూల్స్ కలిపి మీకు ఒక 12 లక్షలు, ఇంకో ఎడిషనల్ ఎక్విప్మెంట్ అంటే ఒక 15 లక్షలు అనుకోండి. 15 లక్షలు వర్సెస్ 100 KLకి ఇక్కడ వచ్చేసి మనకి 5 KL per hour, ఒక 10 lakhs డిఫరెన్స్ రావచ్చండి.
ఒక 10 lakhs వస్తుంది. బట్ ఈ 10 lakhs కి ఇప్పుడు కస్టమర్ అడుగుతాడు, నేను దీన్ని పెడతాం వల్ల బెనిఫిట్ ఏంటంటే ఇప్పుడు మనకి మెమ్బ్రెన్స్, ఆర్ఓ మెమ్బ్రెన్స్ ఎట్లా సేఫ్ ఉన్నాయి అనేది మనం రైట్ ఇవ్వాలి, అంతే కదా సార్?
అవునండి, అవును.
రైట్. ఇప్పుడు అదే డీల్ చేస్తున్నాము 2-3 కేసెస్. ఎనీవే, ఓకే
ఓకే అండి, థ్యాంక్ యూ.
రైట్ సార్,
కిషోర్
ఫర్ ద సపోర్ట్. యా, పవన్ గారు.
సార్, ఐ రిక్వెస్ట్ ప్లీజ్ డోంట్ టాక్, ఐ మీన్ మన వెండర్స్ కావచ్చు, మన డైరెక్ట్ ఛానల్ పార్ట్నర్స్ కి డోంట్ టాక్ ఆన్ ద ప్రైజెస్. ఓకే, మన డైరెక్ట్
కిషోర్ ప్లీజ్ అండర్స్టాండ్ దిస్, దీస్ ఆర్ బాల్ పాస్ ఫిగర్స్, right?
Got it, sir. Thank you.
We are not telling any exact figure, we are giving a range, a tentative range. See, some of the people want answers, real answers. Our presentation should give them realistic information. It should not be based on some theory. Right. And if somebody is taking a customer for ride, for example, Somshekhar gar, he is there. Tomorrow some vendor comes and tells him for MBR, you pay me 50 lakhs another. Now he has knowledge, right? Right? Our job here is to provide the knowledge. The knowledge includes little bit of commercial knowledge also.
Absolutely. Definitely.
Okay, but your suggestion is well taken. Thank you everybody for joining out here today. You can watch this